Hello, everyone. Um, welcome to the party. It's gonna be fun. Oh, cool. All right. What are we doing? Just let me set up. I have like spooky slides because augmented reality is really, really spooky. So, just welcome. Who am I? I worked for Magic Leap for over 5 years. I've worked in the game industry more than 18 years. I've made video games since I was 10 years old, which is pretty cool. I don't really know how to do anything else. It's like, that's my natural gravitation. Let's just make crazy stuff all the time. We all got made redundant from Magic Leap, and so we co-founded NZXR out of that. I really just want to work on anything AR, but I can still make a killer screen game in my spare time. I make gin as a hobby, sometimes robots, and lots of other dumb stuff. Quiz me later. I'm full of shit ideas. Disclaimer. These are like my opinions, and I've stolen a whole bunch of stuff as well, which is real cool. From people that are as fully sick as me. What the hell is augmented reality? What's it for? What does it do? And these slides are tiny, and I keep looking at the screen. So I stole some definitions from the internet, and I found them all horribly lame. Because I've worked in the space, helped invent stuff for augmented reality. And like, if you just Google it, it's like, a technology that superimposes a computer-generated image on a user's view of the real world, thus providing a composite view. That's technically true. It does that, but it doesn't capture everything. It's very, very fucking shallow, and I find error in it because it says computer-generated, and it's like, I don't want it to be. I don't want the definition to provide medium. Then we have like something from Wikipedia, which is like augmented reality is an enhanced version of the real physical world that's achieved through the use of visual elements, sound, or other sensory stimuli delivered via technology. I don't like this because it's backwards. It doesn't put the emphasis on the user or their perception. So let's like break it down real simple. So first step, augmented reality alters the perception of the user via sensory stimuli. It's your first thing. Always think about what you're doing to the user, how they're perceiving the world, like how, whatever you need to make, you're affecting someone's body. Augmented reality constructively or destructively modifies the world around the user using spatialised virtual constructs. So that's like, we have this water bottle, and it's real, and this water bottle is virtual, and we've modified it. It's in space. It is there. And this is the big one. Augmented reality harmonises real-time human body interactions with compute. So that is just a big sentence for you wear a computer. It's around you. It's like when you pull your phone out, you're like, cool, now I'm in the phone and I'm holding it. But you put your phone in your pocket, you're technically wearing compute at that point. It's doing stuff in the scenes. It's notifying you. You get a thing on your watch or whatever. Here we go. We're wearing compute. And we're trying to make sure that all of your abstractions, all of your keyboards, all of your mouses and shit go away. You're just using you as a vessel to interact with compute. So this is my definition, and feel free to correct me, update this. But augmented reality is a technology that alters the perception of the user via sensory stimuli, constructively or destructively modifying the world around them using spatialised virtual constructs so the user can perform real-time interactions that harmonise the human body with compute. That's augmented reality. What the fuck does that mean? We're trying to save people time, so I've got a couple of contrived examples. If you're like a car mechanic and you're under the car and it's like a real chop shop car, so you don't have no idea the parts in it, right? They've replaced the diff for something else that's not standard. They've modified it. They've got a different exhaust. And you're trying to fix this shit. You have to get up from the car, use the computer, look it up, look in the manual, take your phone out. Oh, it's just fucking shit. What if you could just look at the diff and then it would project exactly what diff it is, and you'd be like, cool, now I know how to fix it. You just have this like inherent understanding because the computer helps you understand the world easier, faster. I have a meme that I promised a friend that I would say, because we say it all the time. No keyboards, no mice, no screens, no desks, no chairs, no cords, no drugs, no threesomes. No shirt, no service, no carrots, no onions. What else is there? No bushes, no bus stops. It's just, it's contagious. Keep it going. So remember, no drugs, no threesomes. So you wear compute and you access compute around you wherever you are using your body as the interface as well as the real world. It's kind of what augmented reality should do or does or will do. But how do we do it? This is my cool drawing. It's kind of like a little Kabbalah, little uterus kind of thing. So we get user input, which is you walking around, doing your stuff, whatever you need to do. We have your data input, that's your traditional like game or whatever, that's all your computer, that's what you want to do. And then you have your world input, which is what the hardware sees and the hardware interprets. And that all goes to compute, and then that all goes to user perception. So we're affecting people's brains and their interpretation of the world by layering information on top of them, trying to harmonize it with their body, because we've interpreted everything. We've interpreted your input, the data we need to put on the world, and we've interpreted the world. We've put it all together in a nice little tiny package. So what's user input? So you have your macro position, which is I'm here, now I'm here, and now I'm here, right? That's generally it. Like you can use GPS or whatever, but the computer knows where you are relative to the world. You have your head position, so that's your up and your down, your left and your right, and these are very important. I am talking more about like wearable compute like Magic Leap or HoloLens, but this does translate to phone. You just have to ignore head and hands position and just aggregate it as your hand, as your phone position. Your hands position, so you could have a controller or you could pick up where your hands are. You have your eye gaze, so my head's pointing this way and I'm looking over this way. The computer knows where I'm looking. You have your voice and you have different biometrics. You can pick up a lot with a headset, so most people don't notice, but your head moves when your heart beats, just slightly, and little tiny IMUs can pick that up. You can do a lot of stuff. You can have like intentional biometrics and stuff if you want. But we have all of this fucking great input. So it's a little example. So if I'm pointing at that water bottle and my head's pointing at that water bottle and my eyes are pointing at that water bottle, it's almost a guarantee that the computer knows that I'm pointing at that water bottle. But if my head's looking at that water bottle, my eyes are looking over there and my hand's looking over there, it's like, it's not a guarantee that I'm looking at the water bottle. We'll know something, don't worry. Your data input, so this is your typical game stuff. Your 3D objects, your spatialised audio, your user interfaces, and your rigid body physics, and any kind of network traffic, right? This is like, we all make games. This stuff is like the easy part, comparatively easy. So I just did that. Then you have your world input, so your world mesh, your semantic recognition. So AI will be like, oh, this is definitely a table, and this is a chair, and this is carpeted floor, that's a ceiling, it's a wall, it's a door, it's a window. Your light temperature, so basically like the amount of lumens that are in the room, we can like adjust our content to reflect that. Just general noise, you need to cancel out noise. People or animals, so like cutting, the computer will be able to like be like, well, that's a person. We're going to ignore that, or we're going to look after that quite carefully. Same with animals. Internet of Things devices, so if you got like light bulbs and smart speakers and stuff like that, they can all kind of come in as well. Your GPS, your global position, like where you are in the world. and general image recognition. So if we need to do QR codes or something like that, this is all kind of really important world recognition stuff. What I found really challenging about working in Magic Leap is that you had to start from scratch. So put it all in the bin. A lot of people kind of, I've heard this a lot and I've done it as well. You don't quite understand the technology, so the first thing you do is like, let's make a game about ghosts, because we don't need to understand the world. Ghosts can just come in through the walls and stuff like that. Because you're just trying to find this really nice space of where you're comfortable and you just, like, I don't know how the technology works. I'm going to put what I know in it, and it doesn't work all the time. So just put everything straight in the bin. The user has to believe that the augmentation is real. So if it quacks like a duck, it might be a duck, and not be. The experience has to look real first and foremost. The experience has to sound real, and the experience has to interact real. Wait, let's go back. Talking too fast. So, if you have like an object and it's flipping through the table, it suddenly doesn't look real. You need to know that the object is on the table and it's there. It has to sound real when you tap it and believe it, and it has to fall. You have to be able to pick it up and put it down. It's actually necessary right now. I like this analogy. Like, if you're the only person who can see something, you're insane. So if you're wearing like a headset and no one else can see what you're doing, you're over here and you're like, wait up. You're wearing your special glasses. This is an excuse to wear sunglasses inside. You're wearing your special glasses and you're like, cool, doing stuff over here. It just looks fucking naff. But if you're the only person who can't see something, then you're insane. So here's my fucking cool joke. Who wants a tennis ball? Sick. You can tell me that's real, right? Yes. And you can have one. I'm gonna give all this out because I don't want one. Anyone else? Oh, thanks. One more. Fuck yeah. Coordination. Someone over there? Yeah. One more. All the way to the back. Oh, should play cricket. Right, so everyone has verified that those balls are real. But this ball in my hand right now is real to me. But you can't see it, right? Right? Now you all wear your special glasses, and now you can see the ball. It's really cool. Where's my... who wants this tennis ball? Who wants to play Foursquare? The experience has to be seen and heard and interacted with other persons in real time. That's the main pitch. That makes it all believable. That means like our surgeon friends can all agree that like someone's heart is fucked, right? They can all see it. They can all see like a digital map of it, something like that. Unfortunately, this is where it gets like really technical in your design and your implementation, and it just like not only was the initial concept of augmented reality difficult, it means that you have to make everything multiplayer or multi-user by default. Also, the experience has to be recorded, because if you and your friends are just having a laugh, you might need to show other people. You need to take pictures of this augmented reality. You need to be able to pass this information on. So, even in a single-player experience, you might make the best single-player game in the world, right? But you still need to be able to film it. So this is a very challenging thing. You could wear a headset and record it with your phone. I've worked extensively at Magic Leap to enable this to happen. We even made a trailer for a thing that got canned, so I can't show you the trailer, but it's all recorded through a phone using just AR kit and the screen recording. It was all really nice. You could take photos. It was great. But it allowed this kind of novelty. You weren't recording from someone's point of view. You were able to describe and portray what you were making in a really elegant way. Understanding the real world. Oh, wow. Cool, I don't need to do the thing anymore. So getting a world mesh is really hard. And what I mean by that is that you have, the computer needs to understand basically what the world is. So we generate a world mesh. The computer looks at something and it's like, okay, well, we've got some flat surfaces here. And we'll come down and it's like, there's a gap here, there's a floor here. It requires the user to, take their phone out, like walk around, like stand up and down. Because the computer isn't going to do it by itself because we're wearing a computer. You have to get the user to do it. The other thing is that you can't just build static levels that will fit into the world because you will never know what the world is as a developer. You have this like arbitrary amount of information. It's either it's as small as it's big. It's like you can't just be like, I'm going to build this amazing scene and I'm just going to plonk it in the world. Before, when I mentioned like the ghost story, everyone gravitates towards ghosts when they first experience or start developing an augmented reality. The other one is like people go straight to a board game. They go skeuomorphic. It's like, we can make a board game here. And I'm just going to say out loud that every single one of those board games will suck because, well, just make a board game. You don't need to put it in augmented reality. Just go make a board game. But in that example, you could theoretically make this really static, lush, delicious level and put it on the table. But then you're faced with it's small. It's not at human scale. We're not using our bodies anymore. It's just on the table. I mean, well, yeah, like you might use your hands, you might move some tokens around, but it's not in your face. It's not natural. It's kind of shitty skeuomorphic design. So what we really need to do is kind of like this combination between user-placed objects and heuristically placed objects. So you can populate once you have a world mesh and you know its quantities. Like, so we have this room, it's all really nice. We know that like, that's a wall. We can say like, okay, this content, we know that it stick to walls, we can put it on the wall. And this content on the floor, we know that it can go on the floor, its content can go on a table. And you know kind of roughly that it'll work out because you'll have all these kind of, you might need like, oh, I need a table at least this big to put content on, which is another kettle of fish I'll get into later. But what we really want to do is say, hey, user, go place some stuff where you think it fits, to kind of make this nice transition. Fuck me. If the user doesn't position the object in space, then they don't know where it is, and even then it's troublesome, because they might not know why they're positioning it in space. Why is my mouth dry? Getting the user to understand why they're putting something in space is like a hurdle, because if they haven't experienced the software before, they don't know why they're putting it there. So these are like tips. I'm just going to go through them. So like get the user to scan or map the environment is troublesome because the words scan and map don't make any sense to someone. Like an experienced user perhaps, but like a new user will be like, I don't know what I'm supposed to do, because they have to get the computer to look at the world. They have to move around, so you might want to guide them. Being like, hey, we've kind of got this part of the room done, right? But we really kind of want this part of the room done. And so you're like, oh, look over here, look around you, look up, look down, look left, look right. You might need to have particular world mesh requirements depending on your application. So if your application is just like floating in space, you have no real world requirements. But at some point you might want to put stuff somewhere. And so you have this, you really need to ask the user or inform them what they need to do. So it's like, you need a table, you need a floor, you need a ceiling, you need a long distance, something like this. Augmenting the world organically is kind of like that heuristic thing I mentioned. It's like you can just have stuff pop up. That's really helpful because when you're in augmented reality, it can just be like staring at a blank screen. If there's nothing augmented, then they're just wearing glasses. That's it. And then the other one is like use semantic recognition to your advantage. So it's an upcoming technology, but like if you know that, if the computer knows that that's a table, it's a table. So if you want to put stuff on the table kind of thing, put it there. There's a concept of persistence. So persistence is that the user has already kind of scanned this room, and that idea is saved. So we're able to use it across multiple experiences, even between different applications as well, or multiple sessions of the same application. Basically means like I load up the app and the computer remembers the room and it loads in the old data, and that's sometimes handy because the space can be recalled and pre-existing augmentation can be applied. So if someone did leave this water bottle on the table and then 3 days later they come back and open the application, the water bottle can still be on the table. Water bottles are a bad prop, but that's all I got. It's incredibly useful for multi-user experiences. That means like no one has to scan anything. No one has to kind of set up stuff being like, oh, I need to, wait, everyone stop. I just need to scan the world. Cool, I scanned the world. Now you can come into this multi-user experience. It can just load up straight away. Everything's really fucking fun. You can allow to update the space. Sometimes this is taken care of, sometimes not, but you can ask the user to like ignore the persistent space, and in the future it'll allow you to kind of create public spaces where, okay, this room is already mapped, and then any other user with a augmented reality device can come in and be like, I don't need to scan it because someone's already scanned it before. 2D and 3D UI are both incredibly useful. My thing is that if it's paper-like, use the 2D UI, but if it has 3 dimensions, use 3-dimensional UI. And what I mean by that is like, if you have a list of something that you need to do, like an options menu, right? That is still best preserved as a 2D UI as a list. Just try to think of an options menu in 3D space. You're like, oh, I need to turn sound off, so I go sound, turn off, and then I need to turn the music off, and I do something over here. It's just like, no, just pop up a little screen and allow the user to be like, I want the sound off, thank you. Everyone knows this kind of paradigm. Don't try to like over-design or over-complicate something when the solution is already quite elegant. Using 2D UI, so the UI will still be spatial. It'll be like a piece of paper, just be floating in space. So you can use like telescopic pointing because where that menu is in space might not be reachable. So, yes. It's over here, and I can't point it, I can't click it. So you might want some kind of magic ability so that we can telescope and be like, oh, I need to do that. Like HoloLens does it quite nicely with its little clicks, and it has little pointers or fingers. It's really great. And like I said, like you can use spatially positioned menus, so we can put a menu over here that you can walk towards and be like, oh cool, I'll just use this menu, it's really good. Or you can softly tether the menu to your head position. So one thing is that if you hard tether something, so you lock or like parent menu to someone's head, it looks really janky because every time you move your head, the menu is just moving one-to-one with it. So what you really want to do is like have it in space somewhere, and it's dead to your head. So when you're looking at the menu, you look over here, it just comes back, and you can kind of close your menu, do something. Single click selection as well. So we just want really nice, easy confirmations. We don't want like double click. We don't want to use sliders or anything like that because they're annoying. Like they're really fun on a smartphone, but they suck in space. With your 3D UI, if it is 3D, then make UI around it. So I want to be able to reposition, reorient, and rescale objects. So if I wanted to rotate this, I can just do it with my hand. Why would I use a menu kind of thing? Why would I be like, oh, I need to rotate it like this much, and then it rotates. It's like just use your body to rotate stuff, scale stuff. One thing was that came up at Magic Leap a lot when we tried to make 3D UI is that having too many choices often left the user confused, and they didn't know how to progress this this interface. Like, just how to explain it without dancing around too much. The UI had to signal to the user that, like, hey, there is a confirmation here, you need to do something, and it's one step. And then that UI will naturally kind of progress to its next state. Being like, oh, I need to use this really cool button, and the button progresses, and then like guns pop up, kind of thing. It's like, oh, now I can make this choice out of these 3 guns, and everything's really nice. What else is there? Yeah, basically, if it's paper-like, use 2D UI. If it's 3-dimensionals, use 3D UI. It's kind of obvious. So putting all these first principles together, it's time to laugh yourself to sleep. I did this repetitively at Magic Leap because everything was really complicated all the time, and we didn't know what we were doing until we did it. So the user must be able to know they have to look around and walk around to get a world mesh. They have to know the requirements of the world mesh. They have perhaps look in the correct spots of the room to recall persistence, kind of thing. Otherwise, they'll have to go through the process again. They have to operate a 2D UI, a 2D spatial UI. They have to position objects in the room, and they might not know why they're positioning the objects in the room. They have to locate previously positioned objects in the room, so that's like, oh, that's right, the water bottle was on the table. I forgot, I haven't played this in 6 months or something like that. They have to be able to connect to other users, locally or remotely. And we have to make sure that all of our users are like correctly aligned. That's all of this before your bespoke, your super awesome, lovely experience begins. This is all the fucking bullshit that you have to go through just so someone can be like, now I'm in this experience. Now I can understand what I'm supposed to do with this application. This is where I do more rambling. So does anyone have any questions so far? If I've glossed over anything, just feel free to yell out, because we're going to go down some rabbit holes. So alignment issues. This is where, when you have a multi-user experience, most of the time the application's like 0, 0, 0 coordinate is wherever the application started or where the device booted up. And all these 0, 0, 0 coordinates are different. So like the procedure isn't too hard, but you offset everyone from someone 0, 0, 0 based on where they are in space. But this can lean into content being misaligned, so that this water bottle that I'm seeing is here, and this is the same water bottle that you're seeing, and it's here, or it's here. Content is different. You need to like match up these super fun things. You need to make sure that like content is consistent, that we all agree that this water bottle is definitely here. Because that doesn't make the experience believable. If I'm operating this water bottle, here, and you're operating the same water bottle here, we can't agree that it's the same water bottle. Even though it is, and even though it isn't, because they're technically on two independent computers. So world mesh issues, you're going to get holes in your mesh, and that's something you have to live with, because it's dangerous to assume someone's world. So, like a sexy technique is like if you know where the floor is here, you might be able to do like an infinite plane. But maybe you don't want that, because over there the height of the floor changes. So you will get an object, and you throw it over there, and it will just be hovering in space for no reason, because you've got an infinite plane. The other alternative is that you have a void. You have to deal with voids and holes in your mesh all the time, because users are really bad at getting the world mesh repetitively. It's not that they're bad, it's just that you didn't instruct them what to do properly, kind of thing. We really want to close all of our world meshes by the user closing them themselves. It's like, cool, I've done this, I know where the space is, I've got the whole room, we're good, we're ready to go. You can also do stuff like, we did play areas, so like this wall and this wall are mapped. But if I was to open this door over here, just like this door, and walk outside, it would say, hey, you're leaving the play area, please come back, and we'll pause the game. I find that like kind of a clunky thing to do, but it worked. It told the player that, hey, you're supposed to play here, this is all the information that we want to calculate about the world. But we really want to encourage this movement, this freedom of like, you can do this anywhere, it's your world, we're all running over the top. So you're gonna have to, I thought of another point as I was talking. What was it? Fuck me. No, I'll come back to that if I remember. Locating objects. So, if you are heuristically placing an object, you have to tell the user that you placed it, kind of thing. You have to signal, like if it's important, if it's like critical path kind of object, you have to allow the user to place it or let them know that something exists. And you get around that by like, we call them like glints of like object locators. So, you know, a bunch of 2D UI says like, hey, there's an object here, and we draw like little arrows so that we get the user to kind of look down and be like, oh, there is an object there. I still find that quite clunky as well, because the user sometimes doesn't know that the arrows are pointing to something. It's really hard to assume that. Wait, you shouldn't assume that the user knows where stuff is, kind of thing, because they'll get lost. It comes back to the thing: if you're not rendering an image in the world, then they're just seeing the world. It's not augmented. Similarly, like placing objects, it's tricky. Like, why is the user placing it there? They need instructions. They need to be able to like have this nice flow about placing the object. Interaction issues. This is kind of like, if you have an abstract augmented reality, like 3D model in space, and you expect that the user knows how to interact with it and they can progress it, you need to instruct them forward. Do they know that they have to like tap on the top of the water bottle? How do you signal this? You need to signal all of your UI and step the user through it like elegantly. Way more elegant than this lecture. Simple objects are really easy. So if you have a ball, most people will be like, oh, that's a ball, I can pick it up, bounce it. It all behaves just fine. But if you have a machine that you've invented, like we did on Invaders, people don't know that they can grab stuff. People don't know that they can like step through things. People don't know that they have to pick up stuff. So you really need to signal all of your states one by one. Like, here's a shiny thing here. This is the interactable piece. Cool, grab it, take it. Okay, what's the next step? I need to be able to use this device somewhere. What else? Stairs. Stairs aren't solved. They're horrible. Horrible fucking pieces of shit. We mapped this room and there's like a magic staircase over there. And then I just go upstairs. And now I've ruined the entire experience because now I can see in it. I can destroy the world around you. Stairs up to a mezzanine as well. It's like evil shit. We don't. No, if you have a solution, please tell me. Because currently, like world scale AR or like room scale AR, it's very dependent on like, please just stay in the room. Don't move. Don't go upstairs. Don't go downstairs. Don't do anything. But you can solve stairs with multi-room experiences. So this comes back to like your multi-user experiences are local and remote. So you have like a group of people like us, like there's like maybe four people, and we're in this room. And then we have another 4 people in like a room over there. That should be able to link up, and we can have a simultaneous experience in real time across 2 rooms. It's a nice double way to kind of get around this stairs thing, or like single room experiences. You can do it, but you as an individual probably can't migrate from room to room. Location-based experiences, LBX, LBE. These are really good. We did one in 2019. Thomas is at the back somewhere. We went to GDC, and it was real fun, and we put together, and Dan as well, Dan was there, put together this awesome experience where people could experience multi-user wearable augmented reality for the first time at GDC. We did this big show and tell. We would get users in. They would have a cup of tea. They had a tea ceremony together, all virtual tea. They'd have a lot of fun. Then they'll have a ray gun battle. in a contrived space, taking cover and shooting each other. And that gave me a glimpse into like the future. While we nursed everyone through the experience, so they didn't have to do that kind of awful setup I described with like mapping the space and connecting and all of that. Everyone was instantly naturalized to augmented reality. They understood. It's like, oh, I have a teapot, and you have a teacup, and I understand exactly what's going on. I need to pour some tea, drink it, tip it out, everything. Then it's like, oh, it's time for a ray gun battle. Everyone knows what to do. It's like, oh, let's shoot each other with ray guns. It's real fun. They also wore like digital masks that had, when the mask, when you blinked, and when you moved your eyes, the mask would also replicate that. The mask would blink and move their eyes. And when you talk, the mouth would move on the mask, and all the players were wearing digital masks over their heads, which is really cool. Everyone kind of got into character. You couldn't see yourself, but your friend or companion could describe you and what you look like. It was super fun. But because it was so naturalized and so much fun, and everyone walked away being like, holy shit, that was awesome. That's kind of what I want the kind of future arcades to be, of this like really wonderful magic experiences all the time. Doesn't have to be game oriented. It can be like technology or like health as well. You just have like I'll skip that bit. I lost my thought. Reading distance issues. So me, I've got like pretty perfect vision. I can see forever. Nothing is ever blurry until it gets like this close. But far away, see forever. That's not everyone. So if you're putting stuff in space and you assume a reading distance, excuse the prop again, someone can't read it. And if you tether it to their head, they have to like get closer, but the thing keeps moving away. Keep going. So you need to be able to allow people to bring stuff closer and be like, oh, I can successfully read this. Even with their, like, in the future glasses will come around and you'll have your prescription lenses, but some people have really, really niche prescriptions and they might not be able to see that well. So you really need to be able, if you're presenting text in space, people need to be as comfortable reading it as they are a book. They need to be able to draw it closer. They need to be able to change the font sizes. They need everything about it. Simultaneous local and remote user issues is a super fun one. And it's something that we only just touched on as we exited magically. It's really powerful to have, so like me and Joe, we're in the same room and we're having a good time, and then our remote friend connects and then they appear here, actualized in space, walking around the same space that we are. It is really fucking cool, but it's difficult to interpret because where are they facing, so to speak? You have to be able to align your rooms together, if that makes any sense. This is a tricky one to explain. I tried to explain it for like 6 months, but everyone kind of needs to face the same direction, and everyone needs to see the same things, so that the experience is real, the augmentation is believable. As soon as like someone's facing over there, but Joe and I'm standing here, Joe's there, someone's here, I'm going to be that person. Joe and I are here, and they're facing this way, and I think they're talking to us. They're like, why is your back to us? It breaks the illusion. So you really need to think about how you're going to align all of your things. Artificial intelligence issues. This is a big one, like navigating the world. I only have like 3 minutes left, by the way, and this is the second last slide. you start your augmented reality application or experience, and you have almost no world data. And then you ask the user, or you recall via persistence the world. You have no nav mesh. You need to generate the nav mesh so that AI actors can walk around in the space. They can be like, oh, okay, I didn't know a table was there. Cool, I know a table's there, and now I can walk around the table. But if you don't generate this kind of nav mesh on the fly, then your actors will just walk through the table. They don't know it's there, and that will break the illusion. You will have a character standing in the middle of the table, and they'll be like, well, this isn't real anymore. This is make-believe. It's just phenomenally difficult to solve a lot of these things. Nothing else. Does anyone have any questions? Because I'm done. I would say the latter. Try to use the whole environment and both of them together, but it does get tricky. So if two independent rooms have two different meshes, then you're not going to combine those meshes. You just kind of have to keep each room locally, but definitely like maximize as much of the natural world as possible. Even though that might not be kind of make sense or be kind of solvable, that's kind of the attitude you want to kind of solve these problems, is that, okay, cool, this is your space, you've got a table here, and in the next room you've got a sofa. You don't want to combine those things, you want to respect where they are. But you're going to run into like kind of shitty things of where it's like someone's sitting on their sofa like this, right? But then in your room, they're hovering over here like this. I don't think it's just going to take a long time to solve this thing.
How are you trying to solve it? With like the in a multiplayer space, they just say, here's an area you can move.
Yeah.
This is where you should only move. Is that the current kind of solution to it?
Yeah, so like having play spaces is, I don't like them, but it is definitely like an advantage to be like, oh, you can't go out here, just stay around. I have to go. Oh, one more question.
Can you summarize your experience with animation? Like, if you go and make the colors, but then you find out about all these different restrictions that you have, and you try to find a way to make something in that space frustrating or enjoyable.
I can quickly summarize it as fucking awesome. It's rare to work on hardware, and even if you do work on hardware, it would be very like PC-like kind of thing. It would be very like controller focused or something like that. This was all new hardware all the time from day dot, and all experimental. I remember when we called it Pixel Stick. I remember the day everyone turned it on, so that a virtual object was on the table and you could walk around and it would stay on the table. It wasn't just rendering in space around you headlocked. That was absolutely incredible. And seeing that progression of like, this is some weird fucking bullshit, right? And then being like, oh no, it works. Oh, it's really working. Oh fuck, it works. Oh damn, this is good. Even though like, people have their complaints about Magic Leap, it's like, oh, it's only a 50-degree field of view. It's like, you fucking physics the fuck out of that, then make it bigger. Like, it's really hard. It's phenomenally difficult. So, yeah, it was fucking great. I learned so much about myself, what I can do as a human, as a designer, how hard I can push myself how many things I can invent at once as well. Yeah, it was just really great.